In this video, we're going to look at some force diagrams that are a little bit more complicated because we have things happening at angles. So I'm going to start with a box. So it's being pulled across the ground at a constant speed. So since we're at constant speed, we know that the acceleration is 0 and our F net is going to need to be 0. So we'll start to think about things like we've got gravity, right? We've got a normal force. We've got this force of tension along this string. And we've got some friction. So I think we've identified all of the forces are going to go, and then we'll go ahead and see if we can put that on our diagram. So we'll start with a dot that represents our box, right? So we're just doing the box. So force of gravity. All right, we'll do that. Force of gravity on the box by the earth. Okay. And then there's going to be a force, right? We're going to call this a force of tension on the box by the rope. There's also a normal force. All right, notice I'm going to draw this normal force pretty small. We'll see why in a second. So that's on the box by the ground. Okay. And then we've got a force of friction, about this big, okay, on the box by the ground. So something we're going to look at here is this force of tension has two components to it. All right? Just like we could break velocity into components, we can break the force into the components. There's this force of tension in the x direction and this force of tension in the y direction. This force of tension in the x direction causes the box to want to go in the horizontal direction, and the force of tension in the y tends to make it want to go in the vertical direction. And if we kind of look at things that are congruent now, right, what are some things that would be the same? Well, the force of friction would be congruent with this x component of the force of tension, okay? And then if we took this y component and the normal force and added them together, they would be equal and opposite to the force of gravity. So you'll note that the vertical components kind of cancel out and the horizontal components all cancel out, and we end up with our F net equals 0. So similar idea here. We've got a box hanging from two ropes, okay? So we've got gravity, right? And it looks like we've got a couple forces of tension here, right? Some tension, which is the term we use when we're talking about a rope. All right, so we'll start with our box, right? And we got our force of gravity here. Okay, so we'll draw that down here. Force of gravity on the box by the earth. And then you've got two other forces, okay? Kind of like this and like this. All right, and again, they're at an angle, so they have components to them, right? There's the x part and the y part. All right, the x part and the y part. Okay, so we're going to call this the force of tension on the box by the rope. This is also a force of tension on the box by the rope. So I might call these force of tension in the y direction, the force of tension in the x direction. So these are just the components of them, okay? So what things here would be equal and opposite or congruent? Well, these two x components, right? Because our box isn't moving, so our acceleration is 0 and our F net is 0. Okay, what else is going to be equal here? Well, if I take the two y components and add them up, they should be equal and opposite to the force of gravity. So the vertical components are canceling out and the horizontal components are canceling out. And this is all going to be really helpful when you're trying to solve an actual problem. All right, now we've got a box on a hill. So what we're going to suggest is that we tilt our world to match our hill. So I'm going to take my XY axis and I'm going to line them up along the same way that the hill is, okay? So that I can just kind of look at this in the same way it is. So I should have gravity acting straight down again, right? I should have a normal force. That's always going to be perpendicular. And I should have some friction. All right, so I'm going to start with my dot representing my box, and I'm going to draw gravity straight down towards the center of the earth. Okay, you notice I'm not drawing it along the y-axis. My earth is down here. I've tilted my axis. Okay, so this is my force of gravity on the box by the earth. The normal force is going to act right here perpendicular, right, up along the y-axis for us, okay? So we're going to go ahead and draw that there, all right? So that's my normal force on the box by the ground, all right? And then I've also got a force of friction, okay, which is acting right in the same direction as the ground, so right on the x-axis. So that's your force of friction on the box by the ground. Okay. So what we want to do now is think about what kind of components we have. Well, anything that's in an angle to our xy axis, we're going to try to show its components. Okay? So this would be the force of gravity along the x-axis, and that component, and this component would be the force of gravity along the y-axis. So what kinds of things now are congruent? Well, the normal force and the y component of the gravity should be equal and opposite. The force of friction, right, and this x component of the gravity should be equal and opposite or congruent, okay? And that's how we end up with the box just sitting there, right? Like no acceleration, so F net equals 0. So here we've got a skier coming down the hill. Again, we're going to kind of orient our axis to match up with the incline of the hill, all right? And as we look, we should have, again, we should have gravity. Remember, it's got to come straight down towards the center of the earth. A normal, which has got to be perpendicular to the surface, and we're going to have some friction. Okay, so I've got my skier. Remember, the force of gravity has got to come straight down. Okay, so there's my force of gravity on the skier by the earth. Okay, I've got a normal force, right? So that's my normal. It's always along the perpendicular to the surface, so normal force on the skier by the snow or the ground. And then I've got a force of friction, okay? So force of friction on the skier by the snow. So let's look at, first of all, this thing is at an angle to our xy axis, so we can display its components. Okay, this force could be broken into two components, the force of gravity in the x direction and the force of gravity in the y direction. And I think you can see that this normal force would be congruent with that force of gravity in the y direction. And note, though, that this is going to be bigger than that, and that's because our acceleration is not equal to 0. So our net force, there is a net force, and it's going to be coming down the hill a little bit. okay? Sort of the difference between this piece and that piece. So that should give you a little bit of an idea of how to start drawing some force diagrams where things are at an angle.